So give me a function, any function you want. Preferably linear, quadratic, or rational, or square root. If you go beyond that, like x cubed, like a cubic function, it will take us a while.
I'd like for you to provide one.
Yes. Oh, you want me to find one?
I'd like you to think of one.
Okay. Okay, so can anyone give us a quadratic function?
I'm trying to.
That's fine.
No, my strategy behind that was hopefully it would be more like the one on the class.
You can find we can find one right here
Huh? No, it's okay.
on the pink at the bottom. Is this okay?
Yeah, it's fine.
You have it in your hand.
Yeah, I was putting it away.
Yeah, so the other one, the pink one, not the at the bottom. Is that okay?
Yeah, that's fine.
Okay. So let's work on that one. So we have 3x squared minus 5x plus 2. So we are asked to create the difference quotient. We're working on this. Difference quotient for this function. The difference quotient will be given to you. You don't have to memorize it. It's not a big, yes, please. Oh, I'm sorry, Claudia. I'm sorry. Sorry about that. I thought there were two people who came in after I handed this out, but well, when you get to my age, you're gonna forget too. Okay, so it's f of x plus h minus f of x divided by h. And this is what I call the difference quotient, and it's called difference quotient. Not that I want to call it difference quotient, it's called difference quotient. Difference quotient. So obviously, if you remember, there are two things that have to happen here. And we have to remember for any function, every time you determine and simplify the difference quotient, two things would happen. Can anyone remind us what are those things? Other than Tom. Yes, Eddie?
F of x plus h.
I have to determine that f of x plus h. True. But in the process of simplifying the difference quotient, two things will happen. Must happen.
Get rid of everything that doesn't have h.
Exactly, at the top. That's one thing that has to happen. All terms that do not have h must cancel out.
Otherwise, it
Some-
doesn't have one.
It may happen that some of the terms with h also cancel out, but that's accidental. What must happen is all terms without h must go away. Brian? No cell phone. Okay. So what is the second thing that has to happen? What is the second thing that has to happen for any function when I determine the difference quotient? If it doesn't, I made a mistake somewhere. What has to happen? The h in the denominator must go away. The final simplified form may still have h in it, but the h in the denominator must go away. Is this clear? Otherwise, we messed up something. Is that clear, everyone, please? Two things have to happen. Should I repeat or not?
Not to me, but
Will it give you the equation on the test?
The function, you mean?
the difference quotient she means like not the f of x equals, but the f of x plus h over.
That's what I said. You don't have to memorize it. It will be given. You have it on, it's given on the paper, right? At the bottom.
Yeah, but I was just hearing about the test.
Yeah, in this class, you don't have to memorize it. I think it's pretty straightforward, but you don't have to memorize it. Do we understand the two things that have to happen? Yes? Okay, good. So as we discussed, we have this and we have this, but I don't have f of x plus h. So f of x plus h. Please dictate. Other than Tom.
3
I wasn't even thinking about it, but
parentheses
now
x
you got me
plus
going.
h squared minus 5 parentheses x plus h plus 2.
Thank you, Dallas. Now what? Next step.
I'm good now.
Just
distribute everything in parentheses.
You mean square first.
Oh yeah,
Square
right.
first, then.
By the order of operations, I have to square first. Okay. We have an agreement on this.
Foil.
No.
Well, x squared plus 2xh plus h squared.
Yes. Awesome. Minus 5x minus 5h plus 2. Very good. Go back to that agreement. Please, if you have any difficulty, so you don't have to waste your time. We already discussed this, please. So now I am allowed to do what? Okay, so 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 2. Now I can put all these three pieces together. Which three pieces? This is one piece. This one, I already have it right here. It cannot be simplified in any way, shape, or form. So then this is 3x squared plus 6xh plus 3h squared minus 5x minus 5h and plus 2. Ryan, is this okay so far?
Yeah.
Please chime in. If you have questions, stop me, okay? Okay, then I'm here. What should I do to all terms in f of x?
Nothing. Keep it as is.
Yes. So the opposite of this, the opposite of this, and the opposite of this. So what should I write?
Negative 3x squared plus, was it 5 or 6x?
True.
Just
So
the sign.
now I'm ready for the first thing to happen. What was that again?
Cancel out
All terms without
h.
must go away. Good. So dictate, please.
3x squared goes, the 2 goes, and the 5x.
Sorry. So how many terms are left?
3.
3 terms. What do they have in common?
H.
What is left in parentheses? Other than Tom.
6x plus h, 3.
Very good. Very good. I crossed it out by mistake, so now the last here.
Minus 5.
That's it. Do we all agree with this? Yes? Okay, so now what? The second thing happens that we just mentioned at the beginning.
H.
Yes, 1 and 1. And what is the simplified form of this difference quotient for this particular function?
6x plus 3h minus 5.
As you see, there is still an h left in there, but not this one. Is this okay now?
Yeah, but question just came up from my head. But what would we do if, for instance, the terms without h don't all cancel out?
You made a mistake. You have to go back, start from scratch.
Okay, so it's designed so that if you did everything right, it literally can't.
That's why I said, for any function, anytime, the terms without h will disappear. And you will eventually be able to factor out h that will go away with the h in the denominator. Absolutely. Very good. Anything else you worked on? Anything else you'd like to see? Okay, should I worry? Or are we working on?
Can we do a piecewise define?
Yes, yes. Do you have one for me? Let's look at these tests since we are.
There's one right on. We can do that.
Yes. Okay, one at the top. Okay, very good. So we have x plus 1 for x less than negative 2, and we have x squared plus 2 for x greater or equal to negative 2. Now, this question basically comes after what I was supposed to do today. So I think we should postpone it till I finish, and then we'll come back to it. Okay. Also, your test only covers till including 2.5. So, Here's the problem that you had. One form had this problem. I copied it from my test. So let me just see. You cannot do 7, 8 yet. It's going to be part of the next test. Yes, you can do 9. You cannot do 10. It's not part of this test. You can do 11. And you cannot do 12. It's not part of this test. So let me repeat. Test number 1 is everything. So one more time. You cannot do 8. You cannot do 9. I'm sorry. You cannot do 7 and 8. Forgive me. 7 and 8. You cannot do 10. And you cannot do 12. Everything else is there.
7, 8, 10, and 12. Those ones I can't do the math on test.
Because we're going to cover this, but it's going to be part of test 2. So one more time, 7 and 8 you cannot do. 10 you cannot do, and 12. 7, 8, 10, and 12. So please skip these 4 and we'll deal with them next time. Okay, so we'll come back to this, but allow me to finish section 2.5. And as I mentioned, there is one more function that I would like to add to our list of functions from last time. So can anyone remind us how a cubic function, what is the simplest possible cubic function, first of all?
X cubed.
Very good. It is. So f of x equals x cubed. We looked at this function when we illustrated the odd property. So here's the function. I need it for what we're going to see today. So this is f of x equals x to the third. Is this a function symmetric? Is this a symmetric function? Is it odd, even, or none of the above?
Symmetric odd.
Very good. It is symmetric and it is odd. Very good. So we're finally ready to talk about transformations. I think I mentioned this last time, and I will mention it again. Do I really need to know transformations in order to understand this part or algebra or know how functions are created? No. I don't really need to know transformations. However, at the end of the presentation on transformations, you will be able, if you pay attention, you will be able to picture a graph in your head without even graphing it. It will be very easy to understand the function once we understand these 3 types of transformations. Okay? You're going to look at a function and say, oh, I don't even have to graph it. I see the graph with my mind's eyes. Okay? So it's a powerful skill to have. So there are 3 different types. Here they are. Shifts, reflections, and shrinking and stretching. Stretching or shrinking. The first category has 2 possibilities: vertical or horizontal. The second one has 2 possibilities. WRT stands for with respect to the x-axis or the y-axis.
Not the origin.
No. So one more time: shifts, vertical, horizontal, reflections with respect to the x-axis or the y-axis. And stretching or shrinking will be vertical or horizontal. Everything, I hope everything will be very straightforward. This one is the only one that will be something in there that you will say, I didn't really expect this. That's the only one. Everything else should be straightforward. We're going to start with shifts. I'm going to create two functions, and then I'm going to ask you a couple of questions.
Is this 2.5?
Yes, the last section, thank you. The last section before the test, yes. We started it last time, but I forgot to mention it again. Thank you. Very good. Now I'm going to ask you my first question. Which basic function from the list, other than Tom, from the list of functions that we looked at last time and X cubed today, which function did I use to create F1 and F2? Which basic function did I use?
Absolutely.
Very good, thank you. That was the base function. I'm going to graph it. Here's absolute value of X. As we know it, it's a V function. This is the absolute value of X. Now, here's my next question. I'm only comparing the absolute value function to F1 for now. I'm looking at this, and I see X and the absolute value. And then I look at this, and I ask myself, am I from here to get this, am I changing X or I'm changing Y?
Y.
I am changing Y. There is nothing different in the absolute value. It's just that to all these Y values, I'm adding 4. So if this is the graph of the absolute value of X, where am I going? Say it again. Exactly, because I'm changing Y. When I'm changing Y, I do this. When I'm changing X, I have to do this. But since we already decided that it's a transformation on Y, and it's positive 4, it has to go up 4. Very good. So let's graph it. The two branches obviously have to be completely parallel to the original function. Mine is not perfect, of course. No surprise there. So this is up 4. So we are talking about vertical shift of up 4 units. I ask myself the same sequence of questions at any time for function number 2. Am I changing X? No. I'm changing the absolute value of X, if you want, plus 0 to the absolute value of X minus 3. Where will I shift the graph of the absolute value of X? Do we see that? It's down 3? Okay, so let's graph it down 3. Completely parallel to the base function. So this is the absolute value of X minus 3. Is this a perfect graph? 100% accurate? Do I have points in there? Did I work hard? No. Transformations just give us the shape quickly. If we want to go into details, we still have to do some algebra. But obviously, this is a quick way of saying, oh, I know, I see this function already. So this is down 3. So these were vertical shifts. I'm going to create 2 other functions now. I call them F1 and F2, so you understand they're not the same. That's all. Okay, so let's say F1 this time is X plus 1 squared, and F2 this time is X minus 4 squared. Of course, my first question would be, which base function did I use? Which function from the list of functions, other than Tom, I use? I used to create these two. Because I saw him, he was getting ready to say something.
X squared.
Yes, it is. We are using x squared, which is the quadratic, the base, the simplest possible quadratic function. He was just getting ready. I saw it. I saw the wheels turning. Okay. Thank you, Tom, for being so patient with me. Thank you. Okay. Now, of course, my next question is this. Don't say anything just yet. I'm looking at this, and I'm comparing it to this. You can look at this expression as being x plus 0 everything squared. But now I have x plus 1 everything squared. So my question is, am I changing x or am I changing y? Remember, when I change x, I do this. When I change y, I do this.
Seems to me you change the X.
Correct. Now my final question is, and don't say anything just yet, everyone. Which direction? So let's think which direction, because I don't want you to memorize stuff unnecessary. Okay, so where is this 0? When x is?
0.
Correct. We agree? My question is now, where is this 0 when x is? -1. So one more time. This is x squared. Which direction am I shifting x squared in order to get x plus 1 squared?
Left.
Left 1. If you want to remember it like that, that's fine. It's going to be so much memorizing that at some point in time it will fade away. That's why I want everyone to understand it. This expression is 0 when x is 0. This expression is 0 when x is -1. If you want to memorize like that, I'm fine. So 1 to the left. So this is the x plus 1 squared. So obviously it's a transformation on x. So it's a horizontal shift. And this is left 1 unit. Now let's look at x squared and compare x squared to x minus 4 squared, and the same question pops up. X squared is 0 when x is 0. Where will x minus 4 squared be 0? Yes, which means which direction am I shifting this graph? I mean, x squared to get this graph.
Right.
How many?
4.
Yes. So this is x minus 4, everything squared.
Honestly, I just remember it as if it's not in a grouping symbol with X, then keep the sign. But if it is in a grouping symbol with X, then don't. And this is one time you can treat absolute value things as a grouping symbol. Right?
Only because you're thinking of the base function, not because you're doing
Right.
anything to the absolute value. I agree with that. Okay, so reflections now. I should have not mentioned that because I wanted you to tell me what it is. Which base function did we use in order to did I use to create these two functions? From the list of functions. Which one? Thank you very much. So here is the square root of x. Here's the graph of the square root of x. If we don't remember how it looks like, we're going to have difficulties understanding what's happening. Okay, again, I ask myself the same question. I'm looking at this, and I'm looking at this. I have to identify what I'm changing. And I can only change x or y. There's nothing else. So compare this to this and say, I know you are changing. You're changing. Okay, one more time. So when I compare this to this, what am I changing? Am I changing x or am I changing y?
X.
Is that clear? Here is x is 4, but here x is, or this quantity is
Negative.
-4, correct? Right? So if this is 4, this will be -4. So the change happens on x. We're changing x. So then if I have the function, this is my square root of x. If I change x into -x, where am I going?
Like you just said, switching directions.
Right? So if this is the square root of x, and x is positive from 0 to infinity, if I multiply all these values by -1,
It's the same but in the opposite direction.
right? So what type of transformation is this when I change x into -x?
With respect to the
Reflection with respect to,
y-axis.
that's it. So here's the graph. My graph is never absolutely perfect here. It's not, don't even try. So this is the graph of the square root of -x. So this is a reflection with respect to the y-axis. Okay, now let's compare this to this. What am I changing now? Am I changing x? I still have the square root of x and the square root of
You're not
x.
changing anything.
You changing the x output.
The y value. Exactly. I can only change x or y. So since I'm not changing x, I still have the square root of x and I still have the square root of x. And the change occurs outside.
Oh, I didn't see that. I thought that was part of the. I thought that was
Sorry.
part of the radical.
Sorry. Okay? Then I'm changing y. So meaning this. All the y values are positive. If I multiply all these y values by -1, positive y, negative y. So the graph will look like this.
So it's with respect to the x-axis.
Correct. So here's the graph. Let me use blue. This graph is negative the square root of x. All y values, these y values were multiplied by -1 to obtain that graph. Now I'm going to look at a combo. So let's say f of x equals negative the absolute value of x plus 4 and -3. The question is asking us to list the transformations and graph them. Note, transformations must be presented in the order of operations. What does that mean? Here's what it means.
Left to right.
If you, in a way, you're right, in a way. If you ask me to evaluate this function for x equals 5, which operation will I perform first? You want me to evaluate it for 5. Which operation will I perform first?
Minus.
No, I will not start from the minus.
Adding 4.
Exactly. So first I have to add 4. When I'm done adding 4, what do I do next?
Add 3.
No.
Subtract 3.
No, not yet. I'm done with the absolute value. I added and I'm done with the absolute value. What will be the next step?
Then opposite.
Choose distribute.
I have to multiply. I get only one number, so there is no distributing here, right? So for x equals 5, I get one number. I get the absolute value. What do I have to do next?
Combine.
Multiply by -1. When I'm done with that, what will be the last step? Exactly, subtract 3. In the same order, I have to present the transformations. Okay, ready? What is the base function used for this?
Absolute value of x.
First transformation on the absolute value of x will be?
To the left 4.
Very good. I have to write x plus 4, which is left 4. Number 2.
Down 3.
No, that's exactly what I said. No.
Flipped with respect to the x-axis.
Awesome. Reflect. See, you're not even graphing it, but now you picture the graph already.
Because I've done this before in 11? Yeah, 11.
Good. Reflect with respect to the y-axis. Because this is outside, does not touch x, is the outside. This is now the function that I apply this transformation to. This one was applied on this. 2 is applied on 1. And now 3 will be applied on 2. What is the final step? What should I write as the third function?
Down 3.
Negative x plus 4 minus 3, which is indeed down 3. So before we even graph this function, let's just think for a moment. So I have the absolute value of x. Again, where do I go with it first? I go to the left 4. And then what do I do?
Flip it.
Reflect. And then what do I do?
Down 3.
I don't have to graph it. I know how it looks, right? Yes, Eddie?
Why? Okay, on step 2, why do you reflect with respect to the line?
Because the negative sign does not touch x. See, if you compare these two, I'm not changing x. See?
It's kind of like I said, if it's in anything with x, like absolute value bars or parentheses or brackets, then I think then it's, opposite. Then it's.
So see here, in order to determine this, the negative touches x. Here, this was the function that I applied this transformation to. This doesn't change. Only these values, whatever they are, get multiplied by -1. But these values are y values, not x values. So these y values get multiplied by -1. So that's why it's a reflection with respect to the x-axis.
So it's reflected over the x-axis?
Oh, yes, of course. I'm sorry.
Okay. Yeah.
Oh, I'm sorry. Sorry. Of course, with respect to the x-axis, because I'm multiplying y. Sorry. My mistake. Sorry. Very good. So that's what I showed that, but I didn't write what I was doing. Okay. Sorry about that. Good catch. Thank you. Good. So now let's graph all of them on the same coordinate system and move on to the last one. So I graph the base function, which is the absolute value of x. Then I shifted, as you told me, 4 to the left. So this is the absolute value of x plus 4. Then you told me to flip this because it's reflected with respect to the x-axis. So I get negative the absolute value of x plus 4. And then you said the last step was to shift this down 3. So 1, 2, 3. I'm going to shift it here. And this is the final function, f of x equals negative the absolute value of x plus 4 minus 3. Without even graphing it, now you will be able to give me the range. We knew the range before we graphed it. What is the range of this function? Quickly before he says something.
Negative infinity to infinity.
Careful. From the lowest y value till the largest y value.
-3.
Right? This is the maximum point at -3. So from negative infinity to -3 is the range. Very good. Okay, let's look at the last